Hello, my 10 viewers. Hey look, I made an X-ray and I want to share how I did it. So here's the story. I bought this dental X-ray tube on AliExpress. It's kinda cheap, 150 bucks. Well, not that cheap, but affordable, yeah? Look how well it's made, like it's beautiful. Let's put it to some good use. And here's the specification. Also, I bought these X-ray sensitive screens. I bought them in Avito. Some old lady sold the whole pile of them, like maybe 30 pieces for like 10 bucks. So it's a good deal. But they all kinda old. Some of them are like 70 years old. Made in 1951 in Soviet Union in Stalin's era. How crazy is that? Some of them are relatively new, like 30 years old, and made in my city or Moscow or Europe. And there's a manual that says that their service life is like 5 years and they can be stored for not more than 3 years. But we'll see about that. Let's go to the next chapter. So I needed some sort of power supply to power the tube, and my first dumb idea was to use these Chinese shockers. They kinda can output 20 kilovolts, and if I take 3 of them and put in series, it should be enough. Well, the issue was that they are extremely unreliable, and 2 of 3 are burned up really quickly. So I left with only one shocker, and I decided to overload it with like voltage 3 times more that it's designed for. And it works. I was able to produce X-ray, and I was able to trigger the meter for 5 seconds. Then it died too. So my next idea was to use CRT-TV flyback to power up the tube. So I disassembled it, I measured it up, the voltage was correct. I built the setup, and I was able to trigger the meter again and produce some X-rays, but it was not even close enough to glow the paper. So at this point I realized that I need not only the voltage but power, the watts. And as specification says, I need 600 of those. So I bought these 2 high voltage power supplies. Each of them are 30 kilovolts and 300 watts. So if I put 2 of them in series, it will be 60 kilovolts and 600 watts. And also they have flybacks that has built-in voltage multipliers, and they output DC voltage. That's just what I need. At least that's what I thought. Look, the arc is bright and shiny. It looks very promising. So I built the setup again. Yeah, there's a setup. But nothing happened. Look, even trigger doesn't... even meter doesn't trigger. It's not working, and I have no idea why. Yeah, I tried different stuff, but I was stuck. I had no idea why it's not working, because the voltage is correct, the power is correct. What's going on? I don't know. I've been stuck for a while. Yeah, until I met this cool dude, Furry, and he said,
Use the capacitor.
and you know what? It was actually a good idea. So I made this capacitor, and
the capacitor.
look how much difference it made. With the capacitor, the arc,
The capacitor.
as you can see, is way more violent and energetic. Just how I need it. So I built the setup again, and look, I was able to glow the paper this time. And it's blue. I like that it's blue, that it's not green. I like blue. Look, that's my first X-ray picture. Yeah, I was pretty happy about it. It's an 40mm fan, but whatever. And that's the setup that works for me. You can see it's just a bunch of wires and paper, and I don't know, it's sketchy. So I didn't want to leave it like this, so I started to prototype the case. So here it is. It's in Tinkercad, as you can see, very convenient. Also, I found this piece of lead pipe in a junk and decided to build a shield to get rid of stray X-ray, to be safe, you know. As you can see, the lead is very easy to handle. You can bend it, you can cut it with your bare hands. Yeah, it's 2mm lead. There we go. That's how it works. Also, yeah, I cast capacitor in epoxy, so it will not spark again. And it turns out pretty neat. Like, look at that. That's looks good. Also, I designed a turntable, so I will be able to make 360 videos. It's pretty simple. It's just battery, motor, button, and some 3D printed parts. But it works great. So the design of the case evolved pretty rapidly. This is the second iteration. It took quite a while to print, actually. Yeah, here is the assembly video. So initially I was powering up the filament for the tube with these two AC DC converters that are powered from the grid. That's a TPU thingy. Well, powering filament from the grid wasn't the best idea, but it worked for now. Yeah, I also wrapped the shield with a lot of tape because lead is conductive and I want it to be insulated. And it worked. As here you can see that the voltage can be adjusted. So the power supply slides in, then you connect the wires, then you screw it all together. Yeah, then we test. The filament works, the high voltage part works, and only then I put it all together. There we go. Look, it works. Yeah, but not for long. So I faced a lot of issues with this design. It's kind of bad design actually, but yeah, I was able to make like 2 or 3 shots before it breaks usually, and I was stuck quite for a while in this loop when I test until it breaks, then I fix it, then I change something, then I test again, then I fix it, then I change something, then I test again. So I was in this loop for a while. Also, speaking of the old screens, you can see the screen in the white frame is the oldest one and the screen in the pink frame is the newest one. And they work all the same, so the age of those screens, they are tungsten base, I think, doesn't matter. Also, not every experiment was success. You can see the resistors and hot glue idea didn't work. So that idea was ditched. Yeah, there was a lot of fixing, debugging. But eventually I started to figure out how to make it work. See, sometimes it works fine. I like this shot. You can even see the relay. Yeah, that's my thermal sensor from other video. That's just salt. Yeah, that's what I came up with. The battery powered filament, additional section, remove remote button, power reduced filament voltage, and a lots of tape. So let's go through this. Battery and charger. So I make the filament battery powered, and I attached a little charger, the USB charger, and the button. So the high voltage part is completely separated from the rest of the device. And yeah, it works great. Yeah, I designed additional section for cable management, so my cable don't touch anything, and I separated from both parts of the device. Yeah, I ran out of pink plastic at this point, so it's white. These two solutions wasn't enough, and I did more testing. So at this point, I realized that arcs can jump across the whole length of tube, and this is not supposed to happen. So I have way more power, so I reduced it. Here you can see this 80% power, not very bright. This is, hello? Yeah, 95% power. Bright, but not arcing. And of course, more tape, because why not? That's a cool feature. I added a remote button. A remote button controls the octocoupler that disrupts the wire between controller and the driver for MOSFETs. The engage pin. That's how it looks like. It works great, so I can operate this thing remotely. And for videos, you just press and hold. Yeah, since I had so much spare screens, I didn't need so much, so I glued 4 of them together to make a bigger screen, and it worked. Yeah, that was the final design. Since this point, the device never failed again, so this is the final assembly. It's mostly the same with additional section. It's even easier to assemble this way. There we go. Yeah, it's ready. Let's go to taking pictures. Yeah, here I can... I should explain that I'm not exposing myself to radiation, okay? Every time I took a picture, every time the device is running, I'm actually standing in the other room. Yeah, and operating it remotely. Only the camera sees what it's doing. Here you can see there was like 15 something on the meter. Then I take a picture. Then I go to other room. Then there is the picture. Then I came back. And look. I got no radiation exposure, so don't worry about it. Of course, I get exposed when I like shot my arm and stuff, but it's dental X-ray, it's not a big deal. Okay, let's watch more shots. Hey, look, it's servo. I like this video. You can see the gears move. Cool, right? That is the power supply that is filled with epoxy, so you cannot disassemble it. But with this machine, you can see what's inside. And also that shocker from the start of the video. That's Nokia from my other video. Okay, that's just random stuff. Yeah, that is the factory-made rotation table, but it's too slow to my liking. That's an FPV drone. Here's some shots with bigger screen. So this is the hair dryer. And that's the camera. Let's go to videos. Hey, look, that's a DJI drone. You can see the GPS, the main board, the camera, the motors. That's hard drive. You can see through hard drive. How cool is that? That's a vacuum tube. Actually, that's interesting. So it looks like they made from lead-rich glass, so X-ray cannot pass through that through a vacuum tube. I didn't know that. Many people try to make X-ray from vacuum tubes, but they are not transparent. Yeah, that's my hand. I was shaking quite a lot when I first stick my hand in it, but it turns out fine. It's safe. I didn't feel anything. Here you can see some more videos of random stuff. Yeah, high voltage generator again. I like how it looks. Like 360 videos are extremely cool. That's the stuff I will film. Look at this charger. You can see all the components and even individual traces on the PCB. And also check out these like radiation grains on the screen. Isn't it cool? That's an interesting stuff. That's actually a luggage scale, and you can see the wires going from tensor sensor all the way to the controller board. That's 360 of that epoxy power supply thing. That's a Pico tracker that I'm wearing right now. Insta360 camera. And that's a microphone. You can see that it's mostly hollow inside. That's a hairbrush. I don't know what this thing in the middle, but it's there. That's a laser distance meter. That's a toy car. Ooh, that's a ruler. I had a little bit fun with it. Yeah, ruler retracting. Oh, that's my foot. And here's my hand. Well, yeah, that's the end of the video. It was a cool project. I learned a lot. I overcome all difficulties. I even met new friends. So, what do you think? Tell me. Was it interesting? Was it not? Yeah, tell me. Also, bonus part. Why these things glow? Tell me that too. Anyway, that was fun. See you around.